Hello all, welcome to Solvers Club. Today we are starting one of the most important topics in mathematics, that is number system. And in this video we are going to understand what is a number and what are the different types of numbers. Okay, so let's get into this. What is a number? A number is simply a way to represent quantity. For example, 1 apple, 2 books, 10 students. Likewise, numbers help us to count and measure. But as mathematics developed, we realize not all the numbers are same. Yes or no? So we started classifying them into different groups. Okay, and this classification is called the number system. So we will discuss now what are the different types of numbers. First one, natural numbers. What are natural numbers? Natural numbers are counting numbers, where we start counting from 1 only. 1, 2, 3, 4, 5 and so on. All these numbers are nothing but natural numbers. We use these natural numbers for counting objects, right? So, let me ask you one question. What is the smallest natural number? Exactly. The smallest natural number is 1. Why? Because we started counting from 1 only. While we are going right side, the number will increase. Okay, so 1, 2, 3, 4, 5, these are all natural numbers. The least natural number is 1. And what is the largest natural number? There is no largest natural number. Why? Because the numbers are infinite. If we take any number, there exists always a greater number to that number. Yes or no? So there is no largest natural number. Next, and these natural numbers we represent using capital N. Next, whole numbers. If we include 0 to the natural numbers, we will get whole numbers. Okay, so what are whole numbers here? 0, 1, 2, 3, 4 and so on. The only difference is we are including 0 to the whole numbers, and where natural numbers do not include 0. Okay, so the least whole number is nothing but 0, and there is no greater whole number, largest whole number. There is no largest whole number. Okay, and integers. Integers are nothing but negative numbers, 0 and positive numbers, or else we can say natural numbers and negative numbers along with 0, or negative numbers along with whole numbers are called integers. Okay, and we represent using capital Z. So integers include 0, right side of 0 we will write positive numbers, left side of 0 will write negative numbers. Right side of 0 will start from 1 only, and left side of 0 also will start from 1 only. That means we'll write as 0, right side of 0 will write positive numbers 1, 2, 3 like and so on. Here left side of 0 also will write negative numbers, -1, -2, -3 and so on. Okay, and let me ask you one question here. What is 0? Is 0 is a positive number or 0 is a negative number? No, 0 is neither a positive number, 0 is neither nor a negative number. 0 is a neutral number. Okay, and where we use these integers? For example, we use integers to measure temperature. Okay, -3 degrees and 50 degrees, 30 degrees, like we measure temperature. Next, rational numbers. Rational numbers are represented by capital Q, and the rational numbers are numbers that can be written in the form of P by Q, where P is an integer and also Q is an integer. And here one condition is there. What is that condition? Q is not equals to 0. Okay. Why Q is not equals to 0? Any number by 0 is not defined, right? That is the reason the denominator should not be equals to 0. So what are the examples of rational numbers? Here are some examples. 1 by 2, 3 by 4, minus 5 by 2, and 7. Is 7 is a rational number? Yes, 7 is a rational number. Can we write 7 as 7 by 1? Yes, 7. Numerator 7 is an integer, denominator 1 is also an integer. 7 by 1 is equals to 7 only. Yes, numbers, all integers are rational numbers. Okay. So, is 0 is a rational number? Yes, 0 is also a rational number. Why? Because can we write 0 as 0 by 1, 0 by 100, 0 by 1 lakh? What is the value of 0 by any number? Is equals to 0 only. Where 0 is an integer and any number is also an integer only. That is also in the form of P by Q. That's the reason 0 is also a rational number. And here one important thing we need to know, that is decimal form. Decimal form is either terminating or repeating decimals. Those decimal forms also we call as rational numbers. So here we took one example, 1 by 2, right? What is the value of 1 by 2 in decimal form? 0.5. Yes. So this 0.5 is a terminating decimal. It ends here only at 0.5. So we call this terminating decimal form as rational number. For example, I am taking 1 by 3. What is the value of 1 by 3? 0.333, like that the digit is repeating again and again. So these repeating decimals also we call as rational numbers. So we can write this repeating decimal in rational in P by Q form, that is nothing but 1 by 3. 1 by 3 is equals to 0.333 in, and so on in decimal form. So decimal forms in either terminating or repeating decimals, we call those decimal forms as rational numbers. Next, irrational numbers. So numbers that cannot be written in the form of P by Q are called irrational numbers. There are some examples here. Root 2. So what is the value of root 2 in decimal form? 1.414213. Here if you observe the decimal form, it is not ending, it never ends. And here it is not following any certain pattern. If you observe 1 by 3, here we are getting the decimal form as 0.333. The only digit it here repeating is 3. That means it is following certain pattern. If you observe here, there is no certain pattern. Root 2 equals to 1.414213. That means randomly one digit is repeating here. So this pattern, this decimal form is nothing but, we call these decimal forms are non-terminating and non-repeating decimals, and we call these decimal forms as irrational numbers. Okay. And here root 2 is not an integer, root 3 is also not an integer, pi is also not an integer. So we call these numbers as irrational numbers. Okay. Those numbers which are not rational numbers, we call them as irrational numbers. Now, real numbers. All rational and irrational numbers together are called real numbers. Whatever the numbers we discussed till now, all those numbers are nothing but real numbers. Okay. So the remaining topics we'll discuss in the next